Okay, so in this video we're going to be talking about probability and the normal curve and how to determine probabilities of certain values being 1 or 2 or 3 standard deviations above the mean. Okay, so our first example that we're going to work for this in is find the probability that my score is above 1 standard deviation of the mean. Now remember that we have our z-scores to help us with this, and that 1 standard deviation above the mean is the same thing as a z-score of 1. So if I look on my normal distribution chart here, notice that I have my z-score of 1, or my 1 standard deviation from the mean. That's on my positive side since I am talking about positive 1. So all we're going to do to figure out the probability of being above 1 standard deviation or above a z-score of 1 is we're going to add up all of the percentages that we see in each of those things after 1, or each of the sections after 1, and that is going to give us the probability of being above 1 standard deviation. So in this instance, we're going to add the 13.59, 2.14, 0.13, and 0.01, and we get that it is a 15.8% chance that my score, whatever score we're talking about, maybe it's a test score, would be 1 standard deviation above the mean. And this is based on a normal curve, so we are talking about normal data that fits nice and pretty into that bell-shaped curve. All right, so let's do another example. Same kind of concept here. We have suppose that we're starting salary of one university is a normal distribution with a mean of 25,400 and a standard deviation of 1,300. What percentage of graduates have a starting salary higher than 28,000? So in order to do this, we need to figure out where 28,000 is on our normal distribution. So we're going to use our z-scores to do that. So we want to find the z-score for 28,000. Remember, the formula for the z-score is x minus the mean divided by the standard deviation. That's what we were talking about in chapter 5. So x minus the mean divided by the standard deviation. So in this case, that would be the 28,000 minus the 25,400 divided by the 1,300. And we would get 2,600 divided by 1,300, which would give us a z-score of 2. So now on our normal distribution chart, we're going to find that z-score of 2. And we're going to add up all of the percentages above that z-score of 2. So we're going to add the 2.14, the 0.13, and the 0.01. And the probability of a randomly selected student earning more than $28,000 a year from this specific university would be 2.28%. So the chances that somebody is pulled from their graduating class and they're making more than 28,000 is 2.28%. And now remember, this is going to change based on your university. We're talking about one specific university. We're not talking about the entire country as far as graduating and earning that much money. All right, so let's kind of the similar problem here. So suppose that the starting salary at the university, this is the same university, is distributed with a mean of 25,400 and a standard deviation of 1,300. So we haven't changed our mean or standard deviation. But now we want to know the percentage of graduates who are between 22,800 and 28,000. So what we're going to do here is we're going to find the z-score for both of these, for the 22,800 and the 28,000. So the 22,800 is going to give us a z-score of -2. And we already know that the 28,000 from our previous example gave us a z-score of +2. So what we want now is we want to locate the -2 and the +2 on our z-score, and we want to add up all the percentages that are between those two values. So here we've got those 4 values, 13.59, 34.13, 34.13, or 13.59. And so we end up saying that 95.44% chance of pulling somebody who earns between 22,800 and 28,000. And if you'll think about some of the stuff we talked about in chapter 5, we talked about the normal distribution and how many people should be between 2 standard deviations from the mean, so between -2 and +2, and you should notice it's the same value that we're getting here, that 95.44%. Okay, if you have any questions, let me know.